Well, due to popular demand, here I am without a hat. Yeah, your lesson today, guys, is about identifying and sorting quadrilaterals. So this is the moment we've all been waiting for. I've been leaving you in suspense the whole week because up until today, you've just been learning a little bit of terminology that's all going to come together into today's class. So your goal for today looks like this. I can identify and sort quadrilaterals based on their attributes. All right, I just want to refresh your memory here. Quadrilaterals, if we break that down into its root words, quad means four and lateral means side. So we're talking about four-sided shapes today. And you should be able to sort them. I'll give you a little spoiler alert here. There are 6 different types of quadrilaterals we're going to be learning about today. I would imagine you're probably familiar with 3 out of the 6, and so we're not gonna spend a ton of time on those 3 that you already know, but I am going to spend a bit of time going through the 3 that you may not know yet, the ones that are going to be new to you. So let's start off easy. Let's start off with ones that you already know, and again, we're just going to blitz through this slide here because I think you all know what a rectangle is. But a rectangle up in the top left-hand corner here contains 4 90-degree angles. Yes, so in each of the corners or at each of these vertices, there's a 90-degree angle there. Now, the thing about the sides of a rectangle is that opposite sides are equal in length. And so I think a little bit earlier in this unit, we talked about how we could use these little dash lines to show that this side is equal in length to this side here. They are opposite from each other. But then over here on the left and the right side, or the vertical edges here, these are not the same length as the horizontal ones. And so I'm going to use a different marking to show that they're a different length. So we're going to use 2 of those little markings to show that those opposite sides are equal in length to each other as well. So there you go. That's what you need to know about a rectangle. We also talked about this in an earlier lesson, that a square is technically a rectangle by definition. Good. All right, well, let's move on here. Going to go to the second shape, which you are probably very familiar with, which is a square. Squares, again, just like a rectangle, has 4 90-degree angles in it. So that just talking about angles alone is not enough to differentiate or distinguish between a square and a rectangle. But the difference with a square is that all 4 sides are equal in length. And so using our little marking notation here, we could just show that the top and the bottom and the left and the right are all equal in length with one little tick there, okay? So that's what differentiates a square from a rectangle, is just the side length. Squares have all equal sides. Rectangles have pairs of equal sides. Top and bottom are equal. Left and right are equal as well, okay? Now, I just put a little note on here down at the bottom of this that a square is the most efficient way to fence a quadrilateral. Going to give you a minute to let that sink in. A square is the most efficient way to fence a quadrilateral. If you have no idea what that means, let me just explain that to you on another slide here. So let's pretend that you just got a dog and you did some research before buying your dog and found out that this dog needs 16 square meters of space to run around in because it's a high energy dog. And so you've got multiple options for building a quadrilateral that has an area of 16 meters squared. Option 1 here is to build a square that's 4 meters by 4 meters. And yes, if you count it up, there are 16 square meters inside of my little blue square here. So that's one of my options, to build 16 meters squared. A second option would be to build a 2 meter by 8 meter enclosure. That would look a little like this. It's narrower but longer. But if you count it up inside, there are still 16 of these square meters in here, okay? And our third option would be to build an enclosure that's really long and really narrow. So this dog would basically just sprint from end to end here, wouldn't have to worry about turning from side to side. But again, if we count up inside of here, there are 16 little square meters here. So these are our 3 options. Now here's the deal, is if we add up the perimeter around each of these options, we've got 4 plus 4 plus 4 plus 4 here, which gives us a perimeter of 16. Here we have 8 plus 2, which gives me 10. And then around the other side here, we have 2 plus 8, which gives me another 10. So it turns out the perimeter here is 20 meters. And the last option here, we've got 16 plus 1, which is 17. and then another 16 plus another 1 is another 17, so 17 plus 17. Whoa, that's a perimeter of 34 meters. Okay, guys, so hear me out here. All three of these enclosures give the exact same amount of area for the dog to run around in, but this one on the right is actually more than 2 times as much fencing to build. All right, so it's going to cost you more than twice as much to build this fence than it would to build this fence here. So let me go back to that statement I just said. A square is the most efficient way to fence a quadrilateral. Okay, just a fun little fact for you. Okay, let's move on. Now we get into a couple of shapes that you are probably less familiar with. So I'm going to go over to rhombus here. Now, what I want to point out to you right off the bat is that a rhombus is basically just a leaning square. I always call them italicized squares because it's basically a square that had vertical edges, and then you just like kicked over the top of it, and so those edges are now slanted or leaning. So it's got a lot of very similar characteristics to a square, but one major difference, the major difference is that there are no longer any 90-degree angles in a rhombus. All right, because they are leaning over. So some of these are going to be greater than 90 degrees, and these ones over here on the sides are going to be less than 90 degrees to make up for that, okay? But it is still important to note that a rhombus has equal side lengths, like that. All right, so that's a rhombus. In summary, all of the sides are equal. The opposite sides are parallel from each other. Yes, this side here is parallel to this side here, and the left side is parallel to the right side. So it's got a lot, again, very similar to a square. Only difference is we don't have 90-degree angles in it, okay? Next, we have a parallelogram. And so, we just talked about how a rhombus is like a kicked over or a leaning square. Well, a parallelogram is basically just like a leaning rectangle. It's like somebody found a rectangle and they went and kicked the top of it. And so the whole top end of it just shifted over a little bit. So again, very similar to a rectangle. The only difference is that it doesn't have 90-degree angles in each of its corners. But it is important to note that opposite angles are equal to each other. So whatever this angle is here down at this vertex will be equal to what this angle is up at this vertex. Okay, so that may be like 85 degrees. So if this is 85 degrees, this is also 85 degrees. And if these ones shrunk a little bit down here when it leaned over, these ones would have to grow a little bit. So they're a little bit bigger than 90 degrees, but these opposite ones are the same angles as each other as well. And the same thing, guys, with the sides. We know that the top and the bottom are still the same length, just like in a rectangle, and the sides, the left and the right side, are equal to each other, just like in a rectangle. Okay, so that deals with the first 4 here. Now I'm going to introduce you to one that's kind of a category of its own. I can't really explain this to you that it's like any other ones. It's not like a square that's been kicked over. This is called a trapezoid. And a trapezoid, the defining characteristics of that are that the angles or the opposite angles are not equal, which means if I look at my bottom left angle here, and my top right angle, those are opposite from each other in this quadrilateral. They are not the same. All right. So that's different than anything else we've looked at. If you look at opposite angles and anything else that we've looked at so far, they are always equal to each other. So trapezoid is kind of like the odd man out, the ugly duckling of the group here. And that is the big difference. Trapezoids do not have equal opposite angles. Okay. But the other thing that's really important to know about a trapezoid is that it has 2 parallel sides still. Okay. Let me just grab a different color here, blue. You'll notice that the top of my trap horizontal, and the bottom of my trapezoid also runs horizontal. These 2 sides of my trapezoid are still parallel with each other, and that's very important. If these 2 sides aren't parallel, it's not a trapezoid, okay? Finally, the last type of shape here is a kite. Now, I was assuming this was like the third shape that I assumed you knew what it looked like. I'm assuming you all know what a kite looks like. Now, with a kite, we do have opposite angles that are the same as each other. So on the left side of my kite here, this angle here would be the same as this angle here on the right side. Okay, so it does have opposite equal sides. The difference is though, rather than having opposite sides that are parallel, we would have adjacent sides which are equal in length. Okay, let me explain to you what adjacent means. Opposite means like if I'm standing on this side and looking across, uh, that's the opposite side over there. Okay. Adjacent means it's next to. So if I'm standing on this line here or this edge of my kite, the adjacent sides would be this one that's next to it and this one that's next to it as well. Okay, so adjacent means next to. And so the deal with a kite is that it has adjacent side lengths that are equal in length. So let me just put some markings on here just to show you what that looks like. So that means the bottom left edge here is the same as the bottom right edge here. Those are the adjacent sides and they are equal in length. And then the top sides are not the same length as the bottom ones, but they are the same length as each other. So I guess it's kind of like a rectangle where a rectangle has two opposite sides that are equal in length. A kite has two adjacent sides that are equal in length. So there are your defining characteristics of quadrilaterals. Now, some of you throughout this video may have been wondering, well, what happens if I can draw a quadrilateral that doesn't meet any of these criteria? So any quadrilateral that does not fit one of these descriptions is called an irregular quadrilateral. All right, we don't have special names for them. We just kind of group them all together into a big category called irregular quadrilaterals. And for grade 5, that doesn't concern you. You don't need to know about irregular quadrilaterals, okay? At this point, we're going to head on over to IXL and we're going to do skill W13, which is a grade 5 skill. And you're basically going to need to know everything that I covered in this video to skill successfully, all right?